So before we head across to the lab, okay, when we first get in there, what do you put on? Goggles. Okay, no earbuds. There shouldn't be any right now, okay, because I'm talking, okay, because there are definitely no earbuds in there, okay. Make sure your hair is tied back, loose clothing is out of the way or buttoned up or whatever so it's not hanging, because we do have two very strong acids. They smoke when I make them, okay, and one very strong base. It didn't smoke, but it looks nasty. Actually, just looks like a clear solution. But it is nasty, so be careful with everything. Okay, everything is mixed very strong so that we can see all the signs of a reaction. Will we see all of the signs? Is our eyes the only sense we should use?
No.
What else should we use?
No.
Nose. Okay? I will tell you that one of the reactions does not have any visible change. But if you miss the smell, well, I don't know how you miss the smell, okay? Well, if you know, this will still, like, it's the same thing that, like, smelling salts. You know, they make the weightlifters go crazy before they lift stuff, okay? Yeah, it's like that. Like, you can't miss it, even if you're nose blind, you'll feel it, okay? Well, no, you won't, because you won't get that close to it, but you'll detect the smell right away, okay? So just be aware on that one, okay? When we get across, there are a couple of little instructions that I will give you because it's easier to do that when you can see all of the materials, okay? But make sure you have your phone with you so you can put your observations in it as we go. Remember, you want a before and an after observation. So if you're mixing two clear solutions together, make sure that you say that. Okay, and then afterwards, tell me what happens. Is there a color change? Is there an odor change? If there's an odor change, describe the odor. Okay, if there's a color change, don't just say color change. Say it turned bright purple or it turned whatever. Okay, if a precipitate formed, describe the precipitate. Okay, was it just cloudy? Was it powdery? Was it gel-like? Okay, make sure you give good descriptions in those observations. They're worth 3 marks out of 30. Okay, so make sure that your observations are good and detailed. Once we're done, we'll come back here and I'll talk about the analysis. Now guys, this shouldn't take very long. Okay, we're mixing 7 pairs. Right, mix them, have the thermometer in there, okay, so that you can detect any temperature changes. Okay, with it, so have the thermometer in when you actually mix them. Right, don't put it in after, put it in before. Okay, record any temperature changes as well, but guys, it shouldn't take long. You mix them, the results are immediate, okay? Rinse it in the disgust bucket, start the next one, okay? Everything goes in the disgust bucket, by the way, all right? There's a wash bottle in there, okay? And there's a wash bottle on each desk, not that you're really gonna need it other than to wipe off or spray off the thermometer each time, okay? All right, the rest of the instructions I'll give you when we get over there. Okay, now yesterday, we had a couple of predictions, and when we did the reactions today, the reactions did not go the way we predicted, okay? For example, yesterday, we predicted this to be a double replacement reaction. And while it sort of is, it doesn't follow the pattern to the letter, okay? What we predicted yesterday was just going to be that sodium was going to end up with chlorine and that ammonium was going to end up with hydroxide. But what happened in reaction number 1?
And you smell it like smelling salts.
Smelled like smelling salts or a really strong glass cleaner like Windex, okay? That's because this reaction produces a gas, okay? And that gas is ammonia.
My mind is blown.
NH3. And 2 other compounds. All right, so here's what you have to figure out. In this, okay, on this side here, if I know that I've got NH3 on the products, that means that accounts for this nitrogen and 3 of the hydrogens. So what's left is a reaction between sodium hydroxide and hydrogen chloride. If you do the proper double replacement reaction between these 2 compounds, you will get the other 2 products. Okay? And then you can balance out the reaction. I'll tell you that the balancing will be very easy.
So do we have to change our predictions to what?
Don't change the prediction. This is for the analysis. The first question in the analysis says you need to write out the reactions in both word and formula form balanced. Okay? So that's why I'm telling you here, this one did not go the way we predicted.
Did the rest?
Okay? Just a minute. And reaction number 2 also did not go the way we predicted because we said it would be a double replacement reaction. But double replacement reactions only produce ionic compounds. This one bubbled and fizzed. It gave us a
Molecular.
gas.
Gas.
Okay? So, what gas gets produced when you mix vinegar and baking soda? Carbon dioxide. So carbon dioxide is one of the 3 products that is produced in that reaction. Okay? That CO2, okay, will account for this carbon and 2 of these oxygens, which basically means the rest of the reaction is this, which we said could be written this way, plus this. So if you do the double replacement reaction between these 2 compounds, that will give you the other 2 products in that reaction. The rest, if you predicted them correctly, should have gone the way that you predicted. Okay? So in the analysis, and this is really important because people mess this up all the time. In the analysis, you are asked in question number 1, using words and formulae, okay, write the chemical equation of each reaction that occurred, except 4 and 5, you don't have to do those, okay? Write them out, words and formula. So reaction 1, write it in formula form, write it in words, make sure it's balanced, okay? And then question number 2 asks you about the precipitates. 2 of the reactions produced precipitates. What I want you to tell me is, what were those precipitates? Okay, so when you write out the reaction, okay, so if you had AB plus CD, okay, and on this side here you had AD plus BC, I would want you to tell me the precipitate was this one. Okay, how can you tell which one's the precipitate? Okay, yes, so the reaction will have a precipitate that doesn't dissolve, but how will you tell in the reaction which one of the chemicals is the precipitate? Okay, but it won't tell you, you predicted it. So yes, you would put an S in brackets around it. This is where you use your solubility chart. So you predict the products and then check in the solubility chart which of the products is soluble. Okay? For one of them, it's going to be pretty easy to figure out which one is because the other one's pretty common. Okay? So just write out all the reactions and then look at the 2 that made precipitates and figure out, okay, so the precipitate was this compound. The precipitate was this compound. Okay, in reaction, whatever. Okay? Which are the 2 reactions that made precipitates?
One was 6.
3 and 6. Okay, so one of the products in reaction 3 isn't soluble. One of the products of reaction 6 isn't soluble. All you have to say for question number 2 is the precipitates were this compound and this compound. Okay, everybody with me there? That's all you have to do for the analysis. Write up the reactions, words and formula. Okay, balanced, and then tell me what the 2 precipitates were for question number 2. All right, for your conclusion, same as always, copy paste your hypothesis and then explain. Did you see the signs of a chemical reaction? Okay, did you see, did every single one of our reactions show at least one of the signs of a chemical reaction? Okay, if that's the case, then you can probably accept your hypothesis. All right, and then sources of error. 2 sources of error and ways to fix them. One of the ones from the first lab is still valid for this lab. Okay, so you really only have to come up with one more, because you can use one of the ones from the first lab. Okay? All right, questions on the report from you guys? It is due a week from today. All right, so you got lots of time to come in and see me if you got some questions. Don't leave it till the last minute.